Hi, I tried working this problem last night and something crashed, so it didn't save. This is my second shot at this one. So it says if the mean score on a math quiz is 13.2 and 83.8% of the students in your class scored between 9 and 17.4, determine the standard deviation. So here's the way I work this one out. So what I did was look at 83.8. If you divide that by 2, it's 41.9, meaning that if the whole thing is spread evenly across the normal curve, that's 83.8%. So that's in decimal form, of course, 0.8318. Sorry, 8838. And then if you divide that by 2, it's 0.419. So that's our percentage spread, or decimal equivalent of the percentage. Then I looked at the 17.4 minus 9.0 is 8.4. So I'm subtracting the high minus the low there. And so that gives us that spread in those numbers instead of the decimal form of the percent. Then I just want to confirm 17.4 plus 9.0 is 26.4 divided by 2 is 13.2. And that was to demonstrate that we are equally spread across the mean. So we have equal distances there. So that tells us that we can divide this percentage up onto either side of the mean there. And then this 8.4 divided by 2 is 4.2. So 13.2 plus 4.2 is 17.4. 13.2 minus 4.2 is 9.0. Gives us that spread. And that's referring to the actual numbers versus the area under the curve, which is the 0.419. Now, when we go to our table, the way the table reads, when we get a z-score, it gives us that value and below. And so at the mean, we know we have half of the 0.5. Half of the area under the curve is below the mean. We're looking for the area between the z-score and the mean to be 0.419. So when I do 0.5 minus 0.419, I get 0.081. That's the area in that lower tail. So we want a z-score that corresponds to that. And I go down to my z-score chart. And the closest I get for 0.081 is 0.0808. So that's the closest, so that's going to be negative 0.14. Get back to where I was. That's where I get this negative 0.14. So the z-score for a score of 9 is negative 1.4, and I just said 0.14, negative 1.4. So now I use that formula I have, which is the value minus the mean divided by the standard deviation is my z-score. So 9 minus 13.2 is negative 4.2, divided by sigma is negative 1.4. I flip both sides. Sigma over negative 4.2 is 1 over negative 1.4. Multiply both sides by negative 4.2. Sigma is negative 4.2 over negative 1.4. That is 3. So sigma is 3. So I have another one. I don't know why this keeps coming up. Do that. Okay. Now let's do another problem just like that. If it were to open up, there it is. Okay. So I've had this question asked from 2 different students. I'm going to do this as well. It says if the mean on a math quiz is 12.7 and 51.6% of the students in your class score between 12.0 and 13.4, determine the standard deviation of the quiz scores. So very similar here. Let's just verify 12.0 plus 13.4 divided by 2. That would be 25. 5.7 over 2, and that would be 12.7. So that does mean that 12.7 is the middle value between these. So they're equally distributed. And then we'd have 13.4 minus 12.7 is 0.7. Also verify 12.7 minus 12.0 is 0.7. So what does that show me? Now this one's going to might be a little more confusing. It's the same exact process, but we have so many decimals, might be confusing for people. 12.7 is the mean. This value is 13.4. This value is, these are not z-scores. Remember, z-scores would not be like this. The z-score for the mean is 0. That's 12.0. So we have a distance down here of 0.7, distance up here of 0.7. And we were talking about the area under the curve being 51.6. So the whole area is 0.516. That's the decimal form of the percent. 0.516 divided by 2 is going to be what? Well, let's see. 2 goes into 5 twice. It's going to be 258. Let me confirm that on the handy dandy calculator. Pretty sure that's right though. .258. Yeah. Okay. So that means this area is 0.258 and this area is 0.258. Again, our z-score that we would be looking at would be giving us a value for that region down there. And we know from the mean down is a total of 0.5. And this part here is 0.258. So what's that area? Well, what's 0.5 minus 0.258? I get 0.242. So that means this area here is 0.242. Yeah, it looks kind of bad. Let me rewrite that. 0.242. So we will look in the chart and find a value that corresponds to 0.242. So let's go down to the chart. Okay. Oh, look at that, 0.242. We don't have to approximate. So negative 0.7. Well, that's kind of a funny coincidence. I say that, and it's unfortunate, in my opinion, that it happens to line up with the other thing being 0.7, because that can confuse people on the process. So that means our z-score is negative 0.7. So we would do 12.0 minus 12.7 over sigma is negative 1. Or sorry, negative 0.7. So 12.0 minus 12.7 is negative 0.7 over sigma is negative 0.7. Okay. If I flip both sides, sigma over negative 0.7 is 1 over negative 0.7. So sigma would be negative 0.7 over negative 0.7. So sigma would be 1. The standard deviation for this problem is 1. Okay, and that's how you do these problems, given two examples, two different versions of the same problem. So hopefully that makes sense to people. Okay, well, we'll talk to you guys later. Bye.